All right, welcome to the Robertson R.I.T.E webinar. So this is pretty much informative technical edge that we're delivering to you, and we're going to try to do this about monthly, okay? And monthly to bi-monthly, and try to bring you some technical advice and any kind of information we feel to bring directly to our contractors here. So if at any time you have a question, you're more than welcome to click on the chat and ask a question for us. Answer at the time, we will. Now, we do have, at the end, we'd have an actual email address for you to send any kind of questions to that we can respond. And then also, we will be recording this and then posting either this on YouTube or one of our websites. So in a minute here, I'm going to give it over to Dennis Tisch. Dennis is with R.I.T.E Manufacturing, and he's going to discuss the FER changes that will be coming down the road. So without further ado, go ahead, Dennis.
Good afternoon, everybody. Can you hear me all right? I hope you can. I know everyone's on mute, but AJ, I'm good to go?
Yeah, you are.
Perfect. Okay. You want to go to that first slide that we have? Okay, guys. Greetings. I'm the regional manager for on the sales side for R.I.T.E. Currently I live in Milwaukee, Wisconsin, so I know you guys are either in Michigan or Ohio or Pennsylvania. I'm not sure if the front came through yet, but we just had 5 days in a row of 90 plus and high humidity, and last night we had some great storms, and now it's a beautiful 68 degrees and low humidity. So if it hasn't hit you, it's on its way. So that means furnace season is on its way. And we have some changes coming up. FER, which stands for Fan Efficiency Rating. And if you go to the next slide for me, what this basically is, it's in a nutshell, and we'll go into a little bit deeper, is what's going to happen is the federal government is looking for ways in which to be more energy efficient for a number of reasons. But right now, as you know, with the R.I.T.E 98V product line, we're at 98.6 on 3 of our 5 sizes, or actually, yeah, 3 of our 6 sizes, and we're at 98.3 on the other sizes. So basically, we're getting furnaces as from the gas side, the AFUE side, as efficient as you possibly can. So other ways to look at it is look at the usage of electricity. And we used to have a thing called little e, which was really a rating about how much does the whole fan and the energy consumption for the blower, if that was less than 2% of the total unit output or unit usage, if you will, for electricity, it got a little E rating. And usually in the past, we got like a $50 rebate, so forth and so on. And it helped in some other local utility rebates. Basically, what we're doing is we're getting rid of little e, and we're going to basically for the fan efficiency rating. And basically what that does is it's a complicated measurement, and we have a link there if you want to go in there and look at how the measurement's done. It's about 97 pages that explains this. But the bottom line is that basically it's going to make PSC motors for furnaces obsolete. In other words, a PSC motor will not reach the new standards that we'll have to live by. So as of effective on 7/3 of 2019, next year, R.I.T.E manufacturer and all the other manufacturers can no longer build a furnace with a PSC motor. Let me just say it does not affect outdoor units. It does not affect commercial units, but it does affect package units that are 5 ton and below. But for all practical purposes now, what we're really talking about are furnaces. So as of 7/3, basically as of July of 2019, we will no longer be able to build a PSC furnace. Well, basically the baseline furnace will be a constant torque or X13 motor. The good thing about this, it's not a hard drop deadline. We can sell these until we're out of them. You, as a contractor, Robertson can sell them until they're out of them. You, as a contractor, could install them until there's no longer any to install. Basically, just saying that as of July of next year, we can no longer build these units. And as of July, we'll have to start building constant torque as our minimum units. So as you can see, if we slide over to our next quadrant there on the top, you're removing all PSC furnaces. There's going to be an additional cost to the constant torque. Does the constant torque go down in price to get closer to what the PSC is, or does that become the baseline? That's something that the market's going to have to dictate. And we're also going to have to add some additional constant torque to our two-stage offering. We go to the kind of the lower quadrant. As we said this is a sell through. It's a manufacturing deadline. It's not a sell deadline. So you'll be able to sell these as many as you want. So here's a key question where you and Robertson need to have a conversation, because Ream and Robertson are already having this conversation, or on the R.I.T.E side having the same conversations. What is your strategy? If you're in the new construction, or you know that you have jobs coming up, you're going to need to talk with Robertson and say, hey, I need X or I need Y. So there's two strategies here. One strategy is, does Robertson stock up on these PSC motors so you have them in place for as long as you possibly can logically store these, or do you just naturally let these run out and then move to the constant torque, and hence put you into a better, into a higher cost furnace, but at the same time you get a higher return for your installation? So from a contractor standpoint, there can be multiple things. You can say, hey, you can create yourself a sense of urgency in the marketplace that, hey, Mrs. Jones or Mr. Jones, you need to replace it. You might replace it now, because in a short period of time, this cost of these units is going to go up $200 to $300 to you, and get some business now. Or do you just naturally let that course of business and then go ahead and take the extra $200 or $300 for the install? Either way, that's a strategy that you're going to need to talk to, and you're going to need to talk to the folks at Robertson what you plan to do. We're talking to Robertson already, because we have all of our vendors we have to get aligned and let them know how many of the compressors we need, et cetera, that goes onto this. So we've kind of, at Ream, we're going to, as the manufacturer, we're going to have to let our vendors know probably around the first of the year as to what our strategy is going to be, and our strategy will be dictated on what Robertson and other distributors say, and of course their strategy will be based on what your input. So this is a time in our industry, because of change, and it's a minor change, but it does affect a lot of, especially entry-level furnaces, that we need to have some kind of communication between each other so we know what directions we're going. And then the last little thing, quadrant there in the lower part of engineering, is we went back and tested all of our PSC furnaces again to see whether or not any of them could possibly meet that new FER rating point. And unfortunately, none of them do. So it looks like we're moving forward with the constant torque. You can go to the next slide, AJ. So currently, you can see on the condensing side, we have a 98V, which is our mod furnace. We have a 97V, which is the furnace we rolled out, and then we realized that when we had to come up with the downflow version of the mod, we realized that we could, by making some few changes, we could actually make it a 98. So we actually have a 98 and a 97 that we're discontinuing. So if you understand that, then of course we have a 96V two-stage. The 98V and the 97V are our modulating products. If you look at our two-stage, we have a 96 constant torque two-stage, we have a 96 PSC two-stage, and then we have a 95 constant torque single-stage. And then what we call our tier 3, our entry, is we have a 95 PSC, a 92 constant torque, and a 92 PSC. What we did is we brought some of our constant torque models to the market earlier because of other changes happening on the AC side of things that we needed our test cells. So in a way, we got these units to market sooner than we had to be, but we got you covered as we move forward here next year. So what we're going to be moving to, basically when we show the 2020, or if you will, because we will have some sell-through through 2019, is as of 2020, we'll basically have the 98V, the 97V where you see the asterisk and the KSA. The 97 will be in the downflow or horizontal position, and the 98 will be simply an upflow modulating furnace. We'll have the 96 two-stage. So those top tier items are the ECM. Then we'll move into the 96 constant torque two-stage, and then we'll have a 95T single stage, and we'll have a 92T single stage. What we'll be looking to add is we may be looking to add a 95 constant torque two-stage, but right now that is what our offering is going to look like as we move forward. So as you can see, on the top tier items, we don't really change much, but we lose quite a few units when we come down here on the mid-tier and on the single tier. And of course, if you're doing any kind of new construction, or if you're doing multi-families where you might put in the 92P in there, you're going to have to move to a 92T. And as you know, that does come at a higher cost. If we go to the next slide real quick, if we look at our non-condenser, 80%, right now we have an 80% two-stage variable speed, an 80% two-stage constant torque, an 80 single-stage constant torque, and then we have an 80 single-stage PSC, and then an 80 single-stage, basically entry level PSC motor. That 801P and an 801S, I'm not sure which one Robertson carries, but really the difference from there is on the S series, we take out a little bit of the insulation. We take out the bottom pan. We make it as down and dirty as we can for a real entry level. But moving forward, nothing changes on the top. On the mid tier, we go to one unit, an 80 two-stage with a constant torque in it, and then on the tier 3, we'll have an 80 single-stage constant torque. And I should tell you that the nomenclature on the bottom here, that R801SB will change to a C as in Charlie B. And again, that is that entry level where we take out insulation, we take out the bottom. Basically, it's our down and dirty one, but that'll be a constant torque. So you have a down and dirty 80% single stage constant torque, the constant torque that you'd want to put more in your home if you wanted to put a single stage 80 in, the two-stage constant torque, and then the two-stage variable speed. So that'll be our furnace lineup moving forward. I can go to the last slide, I think it is. Basically what this is coming from I'm not going to read all of it, but I'm going to explain to it. What it does is the bottom line justification for why they're doing this. That they recognize that this ruling is going to add $355 million per year to the cost of equipment, which we all realize there's going to be increased cost of equipment. Whatever your politics are, whatever it is, but this is the justification from the Department of Energy that while it's going to add $355 million, is actually going to save over basically $2 billion, it comes out to be, $2 billion per year in operating cost. That will be the savings between a P and going to a T, and assuming some of that T will progress up to a true ECM. It's going to save $312 million in CO reduction and $6.36 million in the NOx issue. So that there'll be a net benefit of just over $1 billion that the federal government has figured out that despite the cost, the initial cost for the higher piece of equipment, we're actually going to see a savings of when we look at the supply, not only to the environment, but also to the energy, whether it's the power plants, so forth and so on. So they've justified this change by showing that there's going to be about $1 billion a year benefit to consumers, to the economy, and to the environment when you put it all said and done. So again, the big thing with this is that this is not a sell-through. So as long as you have those furnaces in stock, you could sell them. It's just that manufacturers will have to stop building them as of next July. I got a couple other things I'd like to just go over, but I guess I'll stop at that point and see if there's any questions.
Okay, so at this time, what I'm going to do is unmute everybody. So you can ask Dennis some questions, basic questions on this. Like I said, if you do have questions down the road, you feel free to email us at our email address. I'll show you a little bit here. But go ahead. If you have a question for Dennis, please let us know. All right. I don't think we have any questions at this moment.
Let me throw a couple of little things at you real quick here. At one time, there was talk about building a kind of a EMC light motor. So there'd be a constant torque, and then we go to ECM. And then maybe there would be something that we could slot in between the constant torque and the ECM. Well, that project, because we showed that in previous slides at various dealer meetings and so forth. That project has been scrapped because the cost, once you put in the extra controls, the cost difference between that and ECM, there was hardly any. So basically, right now, as an industry, we're going to be living with a constant torque and an ECM motor. Those are going to be the two motors that we have. Remember, these are for indoor furnaces only and for package units that are 5 ton and below. And then just one last thing, and then I'll see if there's any more questions, is this has come up a lot. We are working on a 90% 14-inch furnace. It has been added to our roadmap of things that we want to add to build because of the changes that we're seeing, these apartments and so forth, where you got these units in a closet and you can't put a 17.5-inch in. We are working on that, but we probably won't see that for 18 or 24 months. But that's on our roadmap. And we have to go through a whole bunch of, if you will, gates in which we go to fund this thing and so forth. And there's just other projects that have higher priority, but that is on our radar. That's something we're working on, and we hope to have to you at the best in 18 months, probably closer to 24. And lastly, it probably doesn't affect this market, but we are going to roll out a 75,000 90% furnace that has a 5-ton drive. Big demand for in Texas and other large markets that do have a cooling load, but a bigger cooling load versus a heating load. So we are going to roll out a 75,000 BTU 90% furnace, but with a 5-ton drive. Again, big product for Texas, which is the #1 furnace market in the United States. So anything else I can answer, or any questions?
All right, I don't believe there's any questions right now. Dennis, I appreciate you for coming on with us. And if there are any questions, just feel free to contact Robertson's here at this email address you'll see here in a little bit. And now we're going to go into a little bit of the ECM and constant torque values and some of the troubleshooting and some information we can give you guys. So again, thank you, Dennis. All right, so if you're watching online and see the next slide, one of the big differences that they're going to with the ECM motors between constant torque or X13 are some of the ECM motors, or else you're going to have the constant airflow motor, which is going to be your variable speed motors. Some of the things that we've seen and the questions that we're hearing are, hey, what is our cost difference going to be between a PSC motor to an X13 or constant torque motor furnace to hey, what is the difference between a PSC motor furnace to a variable speed motor furnace? On the 80% furnace line, to go from a furnace with a PSC motor to a furnace with a constant torque motor, you're looking anywhere in the range of $200 to $300. To go for 80% furnace from a PSC motor to a variable speed motor will be somewhere between $300 to $400 of a price increase is what they're looking at. So on the 90% furnace line, you're looking anywhere from about $120 to $180 to go from a PSC motor to the variable speed motor from what we're seeing. And they'll be very, very close price when it comes to the constant torque to the variable speed. So those are some of the figures. Obviously, it'll range as they get to be more popular and everything. But for right now, this is where we're at. Now, a little bit about the PSC motors, which is a permanent split capacitor. So it means you have to have a capacitor. You pretty much have a maximum of 5 fixed speeds that you can choose from. Anywhere from 3 to 5 roughly, but 5 is typically the max. PSC motors are approximately about 60% efficient. Okay. They obviously have the capacitor, and so this is why we're going to the ECM motors, or why the industry is going to the ECM motors, is obviously the efficiency of the motor will increase when it goes to an ECM motor. So the ECM motor you're going to see obviously has no capacitor. The variable speed motor is a constant airflow. So we set the airflow up to say 3-ton, 1200 CFM, and it is going to deliver that 1200 CFM. Okay. Then as the system changes, so as the filters get dirty or registers get closed and other things happen within that system or ductwork, the constant airflow will pick up speed, okay, and try to deliver that same CFM. Okay? It's always trying to deliver the programmed CFM, which is programmed from the factory of the manufacturer of the furnace. They are 80% efficient, so they're picking up about 20% in efficiency between an ECM to a PSC. When we go to a constant torque or an X13 motor, the constant torque is not a constant airflow. So it is much like a PSC motor that when filters get dirty, less airflow will be delivered by that motor. So it is very, very similar to working like a PSC motor. Now, it does not have a capacitor, but it is 80% efficient. So the efficiency is about the same as a constant airflow furnace, which is about 20% more than what a PSC motor is. But it is a difference between the constant torque to the constant airflow. So some of the other differences between the X13 or constant torque motor and variable speed. The variable speed you're going to see is really the premium ECM motor. You're going to find it in your premium furnaces. You have a brushless DC motor, 80% efficient, so it's programmable airflow and comfort options. So we can actually set it up in the furnace to lower blower speeds, higher blower speeds. We have much greater control over this motor. Where the X13 is really just controlled by a couple speed taps. It has a maximum of 5 programmable speed taps. One thing we do want to stress, though, just because you have 5 programmable speed taps does not mean that all 5 have been programmed. So you want to refer back to the manufacturer of the furnace to see what speeds are programmed for that specific model furnace. Okay, so that is one thing. So maybe number 1 is not programmed, but number 4 and number 3 are. So you definitely want to refer back to the manufacturer of the furnace's information there. All right, so on the slide here I have up is showing the X13 motor compared to a PSC motor. The X13 motor or constant torque motor, as the filter gets dirty, you're going to see along the bottom there is your static pressure. So as the static pressure starts to increase, your airflow that it delivers will become less. Now you can see it does not drop off as much as a PSC motor. Okay, the PSC motor does drop off much greater as the external static pressure gets higher in the ductwork, causing the motor to have to perform a little bit harder. Next slide here is actually your variable speed ECM. So you're going to see it's a flat line. When I ask for 1200 CFM, it is going to try to deliver that 1200 CFM no matter what your static pressure is. Typically, we don't like to run over a 0.6 to 0.7 static pressure because all filters get dirty in the end. So as the filter starts to get dirty, your static pressure from the beginning will go up from 0.7 to maybe a 1.0. That is what really kills motors in the end, is having too high a static pressure. It's working harder, and that's where you'll see more of your ECM motors start to fail, is at your higher static pressures. Okay. Now the lines you see going down across that red line of the variable speed ECM, those are actually PSC motors, and you'll see as they get dirty filters, their airflow starts to drop off big time. So that's where the variable speed ECM comes in handy. It's more comfortable, and it also delivers a precise airflow for you. All right, I have up here on the slide that some ECM motor tools. So this is one of the largest questions we get is, hey, they're calling in, I need help troubleshooting this motor. How can I do this? Whether you're working on a RITE, a RITE, or an ICP, or anybody else's furnace, it's one of the biggest questions we get. So we highly recommend getting one of the TechMate Pros, okay, or one of the Gentech motor programmers, motor troubleshooters, and then also the Zebra makes a good ECM motor troubleshooting tool. Okay, we do stock the TechMate Pro. It is plug and play, so you can easily just plug it in the motor, and fire it up and see if the motor runs. If the motor runs, the motor is good. So then we have to look more at the control board or wiring harness. Our code number or Robertson stock number for that TechMate is 054161. Again, that is probably the best tool to have on the truck for troubleshooting your ECM motors. Another area I'd really stress for you guys to go to is thedealertoolbox.com. That is thedealertoolbox.com. They have an app as well as on their webpage. You'll find tons of information just on ECM motors and regular motors and how to troubleshoot them, understanding them better. I highly recommend having your service techs go there and check that out. Great information. So www.thedealertoolbox.com is excellent. Also look for it in the App Store, whether you're on your iPhone or through Google Play, you will find it on there. So the Dealer Toolbox app. Another one to look for, I have it on this website, is an ECM service guide. We're going to post this on our website and also try to email it out to some of you guys that are on this today. If you would like this, I can actually send a PDF document of it. It's a little service guide on troubleshooting the ECM motor, kind of going through the step-by-step process from your outdoor ECM motors to your furnace ECM motors to your constant torque motors. Great little service guide there. So if that is something you would like, definitely send me an email. Again, I will have that up here in a minute for everybody to jot down the email address. All right, so a little bit on the troubleshooting of the ECM variable speed motor. That's a constant airflow motor. The motor module, it can be separated from the actual motor and replaced by itself. So that is the head of the motor. If the head is bad, but the motor ohms out good, the windings are okay, then we can just replace the head. We don't have to replace the whole motor. But if the windings are bad on the motor, then the whole thing must be replaced, the motor itself and the module, okay? So if the windings are good, there's no need to replace the physical motor, just the head to it. One thing you need to verify, very first thing you need to check, anytime you power that furnace up, you will have 110 to 240 volts of power delivered to the motor all the time, no matter if the motor's running or not, okay? What controls the motor is a low voltage signal that gets delivered to the motor through the actual control board. So use the ECM motor troubleshooting tools to go from there and really take a look at it. So here you're going to see this box on the lower left-hand corner. It says TechMate Pro. You power it up to 124 volts, and then it plugs directly into the motor. You flip the switch, turn the furnace power on. If the motor runs, then the motor is good. That is assuming you do have 110 volts to that motor. So again, we do stock that troubleshooting tool. All right, next I actually have the pins, the communication pins to the 96 variable speed furnace and also the mod furnace. On pin number 3 and 4, you can power that with 24 volts to the motor, and the motor should run at about 75% capacity. Okay, so that is another way to troubleshoot that motor if you do not have the troubleshooting tool. This is on the 4-pin connector. Now, you must have 110 volt power to that motor for it to run, obviously. But if you power 24 volts to 3 and 4, with the 110 volts also powered to the motor should turn on and run. And that is the R.I.T.E.'s current lineup of furnaces, the 96 variable speed and also the mod. All right, so now we get into the constant torque motor. The constant torque motor, not all voltage taps are programmed. Again, just to stress that, refer to the manufacturer specs. So if you do power one of the taps to 24 volts and it does not run, it doesn't mean the motor's bad. We need to make sure that that tap is actually programmed or not. Okay, they are programmed to specific model units. So you cannot take a constant torque motor or an ECM motor from a Goodman and put it on a ream. It is not going to operate the same. Okay, it is actually programmed at the manufacturer for that specific model of furnace. If we could just stress that. So here is the constant torque motor. Here's the actual plugs you're going to see on the end for the furnaces. Some are 120 volt, some are 240 volt power. Okay, verify your power going straight to the motor. Again, you will always have power at a constant torque or X13 motor. Okay, you have your line, neutral, and ground, or else you have your 240 volt between L and N on that motor. Okay, so verify you have your 120 volt or 240 volt power there. Then you're going to check for your 24 volt power. I'll go back here 1 minute. So you want to check for your 24 volt power on the taps going to either 1, 2, 3, or 4, or 5. Okay, and then your C on the top here is for common 24 volt. So 1, 2, 3, 4, and 5. If they are programmed from the manufacturer, check the wire leads going to those. It should just be a 24 volt signal. So that's a little bit about the constant torque motors. Like I said, we do have a couple PDF documents we can send you on actual getting you great information in your hands, in the hands of your techs. Send us an email to R.I.T.E info@rhsonline.net. That's R.I.T.E info@rhsonline.net. If you send us some information or any kind of questions you have on there, we will actually send out the PDF document. We do have a list of people who have attended right now. If it's clearly stated your name or anything, we will send that to you automatically. So at this time, I don't know if there's any questions or not. I'm going to unmute everybody. If there are any questions, feel free to ask at this moment, and we'll get them answered. If not, you can always send us an email, like I said. Any other questions, let us know. We are going to do this webinar about every month to every other month, and try to give you guys more information. The next one we plan on having is on the EcoNet control, on troubleshooting and wiring and setup and a little bit of diagnostics of it. So any questions at this time?
AJ,
Yeah.
Can I just add one thing? Somebody have a question? Go ahead. Oh, okay, AJ, I know this is not, you guys aren't sales guys, this is on the tech side, but here's just something to keep in mind when you're talking to a consumer. If they ask you, well, what's the difference of all these things? And if you had a furnace that was running on constant fan, and it was a PSC furnace, the energy consumption of that would be the equivalent of having 5 100-watt light bulbs on in your house. That would be the energy usage out of PSC motor. A constant torque is like having 200-watt bulbs and a 40-watt bulb. And an ECM motor is like having a 60-watt bulb. That's the energy usage, the difference between a PSC, constant torque, and an ECM. 500-watt bulbs, 200-watt, and a 40-watt or a 60-watt bulb with the true ECM. That just helps it when your techs are having a conversation with a homeowner and they're asking questions like, well, what's the difference or why? That's something that consumers can relate to. So just a little piece of tidbit. So.
Excellent. Are there any other questions at this time? All right. So, again, I'm AJ with Robertson Heating Supply. I think I know majority on the webinar here. This is Tyler, also here with me. If you send us information to writeinfo@rhsonline.net, we will both receive that information and answer you back. And we look forward to seeing our next webinar concerning EcoNet. And then anything else you guys have input on, please send to us. Thank you, and have a great day.